Well, you guys, I know you didn't think this day would ever get here, but it is. Today is our last um, homework assignment and last set of notes. I'm trying something different. I'm covering the camera, so maybe you won't see the top of my forehead and the top of my ceiling again. Last day, last set of notes, last objective for chapter or unit 8. Last objective for Algebra 2. So with the completion of this, you will have covered everything that you need for your SAT. So today I really want to show you how to solve a rational equation. So that's our objective. We want you to be able to look at a rational. That means it's a fractional equation with variables in top and bottom and be able to solve them. It is a very simple process. One that students sometimes confuse with adding and subtracting or multiplying and dividing. It is a different process, but it's so nice. The first thing that I want to do is make sure that you have a fraction on all three terms, or however many terms you have. So the process to solve. So let me get this in here a little bit. The process to solve is number one, make sure you have all fractions. Make sure all terms are fractions. And if they're not, you may have to put a 1 over them. Are fractions. So in this first example that we have, this 1 has to be put over 1. The next thing that I always do is wrap up the families. So I'm going to put those two together, put these two together. Sometimes I'll write this step, so I'll put it on there for you. Wrap up the families. Okay, they have to be the same families in order for you to be able to use them. The third thing that I'm going to do is I'm going to multiply through by all common denominators. So all common denominators. Covered me by all common denominators. So you have to have one of every kind. Okay? So when I look at my common denominators, if I look at what I have an x plus 1 and an x plus 9. So what I have to do is multiply the entire equation by those two factors, x plus 1 times x plus 9. I'm going to put that over 1, and I'm going to distribute it to the first term, the second term, and to the third term. So all three of them are going to be multiplied by x plus 1 times x plus 9. All right, watch this. So I'm going to say x plus 1 times x plus 9 over 1 has to be multiplied by the first term, which is x over x plus 1. Then there's a plus sign. And then I'm going to multiply these two, x plus 1 times x plus 9 over 1 times the second term, which is x over x plus 9. And I know this seems very long and tedious, but it is not. There's a lot of writing, but when you're finished with the writing, it is so, so nice. So I have last time x plus 1 and x plus 9 over 1 times the last term, which is 1 over 1. All right, now watch what happens with each one of these. Whenever we choose them, we're back to being able to multiply just this little piece together. And you'll see that the x plus 1 takes out the x plus 1. And what's left is x times x plus 9. So I'm going to multiply x times x and get an x squared, and x times 9 and get a positive 9x. There is no more fraction. So we are doing what is called clearing the fractions. And there's a plus sign here. And then the x plus 9 takes this x plus 9 and you have to distribute x times x plus 1. X times x is x squared, and x times 1 is a positive 1x. Then there's the equal sign, and there's nothing to take out an x plus 1 or an x plus 9, so I have to do a FOIL right here. I have to FOIL both of these together. So x times x is x squared, x times 9 is 9x, 1 times x is 1x, and 1 times 9 is 9. And then I'm going to add those together, clean it up, and put it over here. So here's x squared. Here's 9x plus 1x, so plus 10x, and then plus 9. Well, there you go. Now, on the left-hand side, I'm going to clean this up a little bit. So I have an x squared and another x squared. There are two of them, so that means I have two x squares. And then I have a 9x plus an x, so that's plus a 10x. And then it's equal to x squared plus a 10x plus a 9. Now, we know that in order to solve something that has a square in it, if when I try to combine them, they don't cancel out, we know that we're going to have to factor them. So because I have a 2x squared on the left side and a 1x squared on the right side, I want to move the 1x squared over to the 2x squared. And then, unfortunately, I'm still going to have to factor or use the quadratic formula to solve. So the x squared is gone. 2x squared minus x squared leaves an x squared. And then I'm going to subtract the 10x to the other side. Well, that's good because what happens is positive 10x and negative 10x cancel out. And then you can either move the 9 over or you can leave it over here because it becomes just a simple algebra solve. And anytime we take the square root of a variable, we have to remember to do plus or minus, and the square root of 9 is 3. And those are my two solutions. Now, it says to make sure you check this. So to check this, the only thing that I'm looking to do is to make sure when I put this 3 back into my equation, I don't get something that would make a 0. For example, if x is positive 3 and x is positive 3, will either one of those give me a 0 in a denominator? The answer is no. So I check the negative 3. What if I had negative 3 and negative 3? Will either one of those give me a negative in the denominator? And the answer to that is no. So therefore, I'm going to accept both of these solutions. So my two solutions would be a 3 and a negative 3. Okay. Moving on, we're going to try another one. So the other ones that I have, very similar question, but I see right away there's something different in the denominator of this one than there was in the denominator of the second one. I see that this one has to be factored before I can start to do anything else. And this 2 has to go over 1. Everybody has to be a fraction. All right, so this is what I am actually going to do. I have a 3x over an x plus 1 and wrap it up as a family. It says it's equal to 12, and then I'm going to factor this, and it factors to x minus 1, x plus 1. And then I have plus 2, and remember we said we had to put that over 1 and make everything a fraction. All right, well, now that we have everything a fraction, I just need to multiply through by our common denominators. Now, if you're unsure of what your common denominator is, well, here it is, here, here, and here. I have to have one of each of those. So what I need when I get ready to solve this, let me get a red back up there for us. That didn't take a red for me, I don't believe. There we go. So I believe it's still yellow. You know how much I love technology. Create your color palette. All right, let's put a pretty blue in there. I still don't think that that did what I wanted it to do. I want it to be red. How about that? Reset to default. I don't want it to be yellow. I'll just do blue if I have to. Whatever. Here's red. Oh my. Okay, so what I'm going to multiply through by is an x plus 1 and an x minus 1. This one has an x plus 1 and an x minus 1, so I need an x plus 1 times an x minus 1 to be distributed to all three terms. Okay, so here's what I have. And I know this is the tedious part. X plus 1, x minus 1 over 1 times 3x over x plus 1. And then there's an equal sign. And then it's an x plus 1 times an x minus 1 over 1 times a 12 over an x minus 1. Ooh, x plus 1. That's not very neat. Let's see if I can fix that a little bit. Okay. Okay, an x minus 1, x plus 1. And then there's the plus x plus 1 times x minus 1 over 1, and then it's times 2 over 1. Okay, now we're going to mark out all of those that are exactly the same, top and bottom. So an x plus 1 takes one of these, and what you're left with is 3x times x and 3x times negative 1. So I'm left with a 3x squared minus a 3x. Now the good news is there's no more fractions. And then that's equal to, well, I like this one because the x minus 1 takes an x minus 1, x plus 1 takes the x plus 1, and what you're left with is just a 12. And then there's a plus sign. And here's the bummer part. There's nothing to take either one of these out. But the good news is x minus 1 times x plus 1 is what we started with right here. So this is x squared minus 1, and then I just need to distribute the 2. So then it's 12 plus 2 times x squared is 2x squared, and 2 times negative 1 is negative 2. Okay, I'm going to have to get everything together again, and I see that I'm still going to be left with the squared. So more than likely, I'm going to be factoring yet again. So I'm going to move over this negative 2x squared to the other side. And that's going to bring this down to a 1x squared. Okay. I don't have anything else over here to go with the minus 3x, so it goes next. And then I have a 12 minus a 2, which is a 10. But then to move it to this side, I have to subtract 10. So I have minus 10 is now equal to 0. Well, you guessed it. I have a quadratic, so I either factor it, I use the quadratic formula, I use graphing. I can't use algebra with this one because it's got a middle term. My two signs are minus, minus, so my factor signs will be a plus and a minus. I need a product of x squared, so x times x, and then I need a product of 10 that adds up to be a negative 3. So I'm going to use 5 times 2, that's 10, but I need it to be a negative 3. So I'm going to put the negative with the 5 and the positive with the 2. And then hopefully then you remember to set each factor equal to 0. So x plus 2 equals 0, x minus 5 equals 0, and then you solve it. So x is equal to negative 2, and when you add the 5, x is equal to 5. Now, before I accept both of those as my solutions, I need to go back up to my beginning. And if I go back up to the beginning, If I put either one of those values in, well, I get a 0 in the denominator. So if I put a -2 in, so we're going to go with a -2. So if we do -2 plus a 1, if we do -2 minus 1, if we do -2 plus 1, none of those give me a 0, so we can accept the -2. And then if we go back and put the 5 in, we'll put it in a different color. We'll put it as pink. So if we do a 5 plus a 1, we're okay. If we do 5 minus 1, we're okay. If we do 5 plus 1, we're okay. So then my solution are these two. So I can take a -2 and a +5. Alrighty. Your homework, your final one, your homework is this worksheet here. It is number 8. So this is your final homework, worksheet number 8. We will not be having a final assessment over Unit 8. This is it. Unless you request one. If you want to request a final exam or a final summative out of Unit 8, just let me know and I'll write you one in Alex. Okay, well, congratulations, everyone. You made it. I hope you have a great summer. Congratulations.